Okay, so for this last example on the cylinders packet, example 2, find the radius and the base of each cylinder. The surface area is 48 pi square centimeters and the height is 5 centimeters. So this is similar to that problem we did on the last note packet where they give us the surface area and we have to find something. So I'm going to go ahead and draw myself a picture. The height is 5 centimeters, so I'm going to label that here. H equals 5, and then we know that the total surface area is 48 pi. So I'm going to start, I've got my picture now to refer to. Now I'm going to write down my formula. We know it is, I'm still thinking about pH plus 2b because that helps me to remember 2 pi r is the perimeter of a circle times the height plus 2 times the area of the base. The bases are circles, so that would be 2 pi r squared. Okay, so what do we know? We know this 48 is the surface area, 48 pi. So let's plug that in. And we also know our height, so this would equal 2 pi times r times 5 plus 2 pi r squared. Whew. We've got a couple of different r's here that we're going to have to deal with. First thing I'm noticing is that every single one of these numbers has a pi in it. And so that means we can divide, whoa, not that way. We can divide this whole equation by pi, right? And all of those pi's all cancel out. Okay, so now if we look at this, we've got 48 left on the left-hand side. Order doesn't matter in multiplication, so I hope you're okay with me just going ahead and combining the 2 times the 5 and calling this 10r. And then plus, what do I have left over here? 2r squared. This looks like maybe a quadratic because we have that r squared. So let's rearrange the order of things here. Let's set this equal to 0 because we know that's our strategy when anytime we want to solve a quadratic. So I'm going to move this 2r squared to the front of the equation. I'm going to move the 10r to the middle of the equation so that this can be in standard form. And then I'm going to subtract 48 from both sides of the equation, so minus 48. All right, so we have a coefficient on our ax squared plus bx plus c. If this is standard form of a quadratic equation, we do have a coefficient here. So we can't just jump to the end and say what numbers multiply to be 48 that are negative 48 that add to be 10. We have to actually use the AC method. So let's review how that works. So the AC method. Right? It's where you take your A term and your C term, and that negative goes with the 48, and you multiply them together. You find their product in your side work. So 2 times negative 48. By the way, since we're here, let's just go ahead and make AC method our code word of the day. So AC method will be our code word. Okay, so this multiplies together to be negative 96. And then our next step, once we have that product, then we come over here and we ask ourselves what numbers multiply to be negative 96 that add to be 10, to add to be our B term, right? And so what numbers multiply to be negative 96? You could do 12 and negative 8, or negative 8 times 12 would be 96. Obviously you could do 2 and negative 48. That's not going to be it. We're looking for something that would add to be 10. How about 16 and negative 6? I think that would work, right? Those two numbers multiply to be negative 96 and they add to be positive 10. Okay, so from there, let's go back to our equation. Remember what you're doing. Then you're splitting 10 up into 16r and negative 6r, right? Because 16 minus 6, you guys said, was 10r. And then this rest of this problem, I'm just copying down. Our next step is then we factor by grouping, right? So we put things in groups together. We put the first two terms in a group together, second two terms in a group together. Okay, and then the next thing we're going to do is we're going to factor out the greatest common factor out of each binomial, out of each set of parentheses, right? And so first one, the greatest common factor, it looks like there's an r in common and also a 2. So when I undistribute that, when I take that out, that leaves me with r plus 8. And on the second binomial, it looks like maybe -6 is what goes into both -6r and -48. So again, we get r plus 8. And then you ask yourself, I've got, whoops, undo. Okay, and so then we ask ourselves, what does this whole term have in common with this whole term? And I hope you're thinking, oh, they both have an r plus 8 in common. So the greatest common factor of the two yellow terms is we can factor out of both of those an r plus 8. And so that would leave us, when we factor that out, with 2r minus 6. All right, and so, still going now. Now's the zero product properties turn, which says if two things multiply to be 0, then each thing would have to, or one of these things would have to equal 0. So we make two separate equations, right, and set them both equal to 0 to see which one it might be, and solve those two situations separately. I know which one it's going to be. So 2r equals 6 or r equals 3. It's going to be this one because we can't have a negative radius length, right? Whew, that was a lot. So now we know, what did the question even ask for? The radius is r equals 3, and the base of each cylinder, I assume they're asking for the area of the base. So we're talking about pi r squared would be 9 pi. Not sure what format the book will have that answer in, so you could also say 28.3 if it wants it to the nearest tenth. So these would both be centimeters, right? Okay, there we go, guys. That was cylinders.